All right, we're going to be writing component form of a vector if we're given the magnitude and the direction today. So we're going to do a little bit of background information on that first. First things first, to find the component form, we can draw the vector on a coordinate plane with the tail being at the origin, and then we'll let theta be the direction with of the vector with respect to the positive x-axis. So I'm going to start off on this coordinate plane over here. I'm going to draw in an x and a y axis, and I think I'm going to put them a little bit off center just so I have more space to work with over here. So there we go, my coordinate plane. And then I'm going to draw in just a basic vector with the tail at the origin. And I'm just putting it somewhere out here in the coordinate plane. Nothing special about that one. Anyhow, if I wanted to find the component form of this vector, and all I knew about it was that the magnitude of it was some value in the words up there, we call that r, and the angle that it makes with the positive x-axis counterclockwise there is just theta. Then the way that I could find the components for that, the x and the y pieces of the component vector, would be to make a right triangle out of this thing. And with this, I would have a value for r. So that would mean I would have the hypotenuse of this right triangle, and I know one of the other angles. So with that, this side over here, this y side, if I wanted to find that, I could use right triangle trigonometry, and that would be sine of theta is equal to y over r. So y would be r sine of theta. And on the x side over here, again, the value that I know is the hypotenuse, and I know this angle that's next to that side. So that would be cosine of theta is x over r. And if I solve that for x, I would have r cosine of theta. So that's actually where these formulas came from here. They didn't just pull them out of the air and say, oh, let's just make up some stuff and make young people have to memorize them. So it makes sense with everything that we've done so far. Alrighty, so now that I've seen that, I don't really have to draw the picture in order to come up with the component form of the vector now. So if they tell me that vector v has a magnitude of 12.2, that would mean that r is 12.2. And the direction is 57 degrees. Well, then theta would be 57 degrees. Then to find the component form for my x, I would just say 12.2 cosine 57 degrees. And for my y value, I would say 12.2 sine of 57 degrees. And I did not have my calculator ready, so I'm going to do that right now. Okay, so I'm putting in 12.2 cosine 57. My calculator says that that is approximately equal to 6.645. We're going to round to 3 decimal places. And for 12.2 sine of 57 degrees, well, that would be 10.232. So if I wanted to write this in component form, I would make my, my arrow brackets here, and I would put the x component first, a comma, and then the y component. And of course, close it with the arrow bracket there. So this would be my component form. Okay, so there's a second one on the screen here. If you'd like to give this a try, you can pause the video right now and go ahead and try that one. And then once you think you've got the answer, go ahead and play the video and see how you did. If you'd like to just see another example, then just stay with me and we'll do this one together. So vector v has magnitude 8, so r is 8, and direction is 215 degrees, so theta is 215 degrees. So my x value would be 8 cosine 215 degrees, and my y would be 8 sine 215 degrees. And so I'm going to write that in component form by typing those things into my calculator. So for my x, I got negative 6.553. And for y, I got negative 4.589. And that would be that vector in component form. Now, just a real quick thought about that one. The x and the y both came out negative on that one. And if you think about the geometric form of that vector, let's talk about how that would look if we drew it. If I were to draw that one on a coordinate plane with the tail at the origin, like I was doing before, and the angle that they give me tells me counterclockwise rotation from the positive x-axis, well, 215 degrees would put me over here somewhere in quadrant 3. And then I would have my magnitude 8 on that vector, so the length of it would be 8. So because it is over here in quadrant 3, well, I know that the x and the y value that would represent the point that's at the head of that vector would both have to be negative values. So these actually do make sense. All right, there are a couple questions on the Google form for you to answer now. I'd like you to go ahead and do that and then come back for the next part of the lesson.